Hi there, Amir here. A lot of you have been asking me for a course on data structures and algorithms. If this is something you're interested about, please let me know. If there is enough interest, I'll put together a really good course for you to just enjoy and never have to really watch any other video for data structures and algorithms. But it counts. If you let me know, I will probably do it. This one is not an easy one in my opinion. The one that I'm going to be solving to me is somewhere between an easy and a medium, but I will try to make it easy for you. There are a lot of other videos that I have created about linked lists. I think you should go and watch them. But for this one, let's jump into it. Those regular visitors of my channel know that I always have a Jupyter Lab in black. This helps me to explain to you. And I have the HackerRank actual page in white. This one is called Insert a Node at the Tail of a Linked List. So this is again back to the linked lists and nodes within the linked list. Let me see if my zoom is enough. I'll go to 175%. Let me read through the task. I know it's a lot of words, but it helps us understand what we really have to do. But before we actually do that, let me show you the input type because sometimes I find it pretty easy to understand. We will get a number which tells us how many different values will be inserted by the user. And each of these values is a new node within the linked list, if you like. We will have a linked list size of n, and we will just receive these values. All right, let me clear all of this now, and I will continue to the task. Here's the task. You are given the pointer to the head node. You might not know what these two words are. I'll talk to you right now about them. You're given the pointer to the head node of a linked list. So we will be looking at a linked list. I have a really good video on linked list. The link is up the top right. And an integer to add to the list. So we will receive an integer. Well, in the example that I showed you, we will receive 5 integers to add to the list. Create a new node with a given integer. Okay, that's easy. Insert this node at the tail of the linked list. If you don't know what the tail is, I will talk to you about it. And return the head node of the linked list. Okay, the return, or the last thing we will have to return, is the head node of the linked list formed after inserting the new node. Okay, the given head pointer may be null. This is very important. We might start with nothing. Again, bear with me, I'll tell you what it means. Meaning that the initial list is empty. Okay, this should be pretty easy. What I will also do, I will replicate exactly this. So I am going to run with this exact example. All right. I'm just going to jump into the code that HackerRank has given me. I'll have to zoom out a bit. Apologies if it will be a bit small, but if I don't zoom out, I can't show you all the code. There is this little arrow in here that if you drop it down, you will see that there's some code in here. I know it is going to make my video a bit longer, but I would feel bad if I do not tell you what it does. It actually does a lot of the backend work for this HackerRank problem anyways. So I will talk about that really quickly, but also in the execution of the actual code, remember that what we have to do is to create this insert node at tail function. So let me copy that. And I will call this actual task is to complete this. And I will write the word pass, because if I run that now, I will not get any errors. If I don't write that word pass, and if I run it, I will get an error. That's a Python keyword that allows you to have a placeholder, something that is not going to run. It just helps you not to break your code. So this is the actual task. But for me to be able to do the actual task, I need to understand what else is happening here. One of the biggest questions is, how do I accept this input? I know it's pretty simple, but just helps with a perspective. This is where I will be getting this number 5. Let me just explain this a bit easier. This number 5 will be coming from this line, so that's number 1. All of the rest will be coming within this for loop, number 2. So that's number 2, and this is number 1. Now you may ask, hey Amir, what is this bit here? And also, I appreciate that you said this is the function that I have to fix. Okay, that's here. I understand it. Imagining that you're going to teach us how to do that. But then, do we have to understand anything else? I would think some of the things that you need to understand is literally this function. And this function has been defined inside here. So what I will do, I'll only talk to you about the bits that we need, starting with a singly linked list. But before all of this, let me copy these bits because they matter to us. And I will paste them above this cell. Otherwise, it will throw errors here. I understand that this is going to be developed here. And if I come back here, and if you bear with me, because patience always pays off, trust me, there is no value in rushing through things that are fundamentally important. At least that's what I think. And I have pasted all that code in here. So I don't really need HackerRank anymore for now. I will run you through this code very quickly, and I will start drawing, and I think you will really enjoy it because I will show you with graphics how it actually works. You will import some libraries, that's easy, and then you have got two classes here. The first class is singly linked list node, and the second one is singly linked list. Let me extend my Jupyter Notebook page because it's nice and black. I'll scroll down, and this is where I'm going to start drawing and teaching you. One of the things that is super important, and you might think that, hey, this is only a HackerRank question, I need to learn and then move on with my life. But trust me, I have been doing this for 20 years, and I have to do this, and I have to use linked lists every single day because I develop software. And this is a big part of software development. So we are talking about linked lists. Apologies if my handwriting is not really the best. I have hurt my wrist, and I am wearing a bit of a brace. So a linked list, let's think about an idea of a train. Imagine there is a train that has got some carts, maybe just 3, that are connected to each other. This is very important. So let's call this the head. I'm just going to write the head a bit off so that I can discuss all the ideas that I want to talk. And then there is an idea of node. This is your node 1. This is your node 2, and this is your node 3. As I said, I've got a full video on linked lists. I really encourage you to have a look at them. So within each of linked lists, which is this whole thing, there are multiple nodes. What is really important for you to remember is that each node has got 2 sides or 2 sections. One is the value, right? So this one has got value, this one has got value, and this one has got value. And each of them has got a pointer. I will call it pointer. As I said, apologies for the handwriting, and pointer. Each of them has got pointers. In fact, this arrow here, this one, is this pointer right there. This arrow here is this pointer right there. And then you may say, hey, Amir, where's the pointer for the last one? That's a very good question, because there exists a pointer that points at null, because there is nothing. And that's a big sign for us to understand, here is the tail. How do you know it's the tail? Well, because it's pointing to null. That's the end of this train, and this is head of this train. All right, that's easy. I sidetracked a bit, but I wanted to go back to this. I wanted to talk about singly linked list node. I'm talking about one node. If you look at this node, let me just draw the node because that will help me. I will start with a singly linked list node. This is a single node. It has a value. It has a pointer. Well, the pointer is this actual arrow. I like to write it, but you don't really have to. And it is singly linked list node. So that's this thing. Let me go through the code because I want to do a one-on-one mapping of the code and the actual graphics. It says you will receive the data. Well, some people call this value, some people call it data. So let me call it data. I'm not going to call it value. Same thing. I'm going to call it data. And the node data goes inside the data attribute of this. All right. Okay. Let me just make this a bit nicer. Because we talked about it, I'm just going to make my node a bit nicer. Draw it again. And this is the data. And this is the pointer, or sometimes we call it next. So this node data goes in here, and the pointer will be pointing nowhere. This next, which is the pointer, so if I go back, let me write next. As I said, you can call it next or pointer, is pointing to none or null. That's why we're calling this a singly linked list. It is standing by itself. It's not connected to anything. So we're going to use it. Let me scroll down and understand what else are we going to use it. We're going to use, we're going to use the singly linked list itself, not the node. Oh, okay. Because I showed you this. I will show you the singly linked list now. So the singly linked list, let me just draw a singly linked list. This is it. There's a next, data, next, data, and null. This is the end of it. And all it has is that the self.head, which is the head of this singly linked list, starts with nothing. Oh, so my drawing was wrong. Because what I have here is a head, because you can see that the head is called, but it equals none. So this to me, it's an empty linked list. All right, means that it is starting with no train in this station. If you go to this station, there are no trains. So that makes it easy. Now, I will run this cell and I will just hide it a bit because it's part of the hidden code. And I know that my task is to complete this. But before completing this, because I don't really know what I have to do, let me run my example. I will open the example face and I will run this here. I know that this insert node at tail is not going to work, but let me try. The list count is 5. I will be getting a list of 5 elements. Let me enter 5, enter. And when I get that list count, what happens next? An empty linked list, as I said, gets created. So there is an empty linked list created, which looks like this. There is a head, which equals to none. Doesn't have any data in it. Okay, so this is done, this is done. Let's move to the for loop. Now this is going to run. It will run for a range of list count, so it will run 5 times. Well, of course, because we said it's 5 times. It will run for 5 times, and it will ask the user, hey, what is your next number? First time, it is 141. So 141 goes into the list item. And then the function that you and I have to write will take that list item, which is 141, and will also take the head. Well, the head is empty probably, or maybe not, we will see. It takes the head and then feeds the list head to the next element's head. Now, this is a lot of head, 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 head. Let me draw it for you. It starts with an empty linked list because it says head equals none. Now then, 141 needs to come, but 141, before it comes in, I want it to be a node. I don't want it to be just an integer, because if it is an integer by itself, it doesn't really help me. I will have to convert 141 using one of those functions that I talked about to convert it to a linked list node. Well, I already know how to do it. There is a function for me to do it. If I open this magic box, there was one function or a class that allows me to convert some data into a singly linked list node. All right, I think I'm getting there. Let me draw again. So there is a head that is none. Now the user has decided that 141 wants to go inside this train. We will convert it to a single node that has got a next pointing at null. How do I know? Because I'm making it single. I just want to make it a standalone. So that's what I'm putting it as null. And then the next step, if this one was step number 1, number 2 will be actually this, 141. There is a next, which goes to null. And now you may ask, what do I do from here to add more numbers? Well, when you created this, imagine when it's done, the next number is 302. So you have done 141, then the next one is 302. You have to take 302, right? And then also convert it to a single node pointing to null. And what is really important is that this bit that was from 141 pointing to null will be pointing to 302. This way, I will have a better representation. I'll have 141, which points at 302, which points at null. Oh, now I already have 2. And you may ask, what happens after that? Well, after that, imagine this is the last thing you have, 141 pointing to 302, which was pointing at null. What I will bring is number 164. So I will convert 164 which is pointing to null. And I will get rid of this. I'll make this to point to 164. This is what I'm going to do. Let me show you this in code, and hopefully this makes sense. And if you have any questions, let me know. But I think this should be enough for you to understand what we're going to be doing within this function. So I have entered number 5. Next thing I need to enter is 141. When I run 141, it's not going to do really anything. Everything that I explained is not going to happen because my function is empty. I am not doing any of the things that I was drawing, 141 and the head, and none of that will happen because my function is empty. But eventually when I complete it, when 141 comes, then everything else that I was talking about will happen. So next one is 302. Nothing will really happen. 164, 530, and I think I just messed it up. It's okay. I wasn't hoping really that anything will come out of it. What I'm really hoping to do right now, if I put my pen down, I'm hoping to complete this function. Let's have a think about what I was saying. So step number 1 when I was explaining this was when 141 comes in, we need to convert it to a single node that points at null, and here is the next attribute, right? How do I do this here? Well, I have a function for it. Let me go back up here. As I said, there is this class, right, that I can use to do exactly that. So when the new data comes in, I will call new data equals that class. And what does that class really ask me? That class asks me to feed the node data. All right, I will put data in here, and maybe I will call this new node because that makes more sense. All right, I have taken 141 and I have converted it to a new node. This is brilliant. I have a new node now that is pointing to null. That's all right. That's what I wanted. What is really important is that when this new node comes in, it really depends what my train looks like at that time. If at the time that this guy comes in, this new node, I already have a train, that's a different story. But if I don't have any train, I need to start forming my train. So this is going to be through this syntax. If head is none, because I'm getting the head from down the bottom here. If the head is none, then I want you to return new node. The new node will become my train. No train exists, and if you give me 141, I will convert it to a node, and that node becomes my train. So let me just add some comments here. If no train already exists. Now the next point is if there is already a train. I'm just using the word train, but you get the idea. It's not really about trains, it's about linked lists, but I'm just trying to make it easy. If there is already a train, what do we do? Let me draw it for you. This is quite important. If there is already a train, imagine there are 2 carts. Just going to start with 2 carts, make it simple. If there is already a train and somebody gives me the number 176 and says, hey, add 176 to the end of this train. Yeah, of course, I will convert this to a node. I understand that. And I will make this the last cart into this train. So I will make sure this points to null. That's easy. That's step number 1. We have done this. But remember that this is pointing to the null. And if I want to add this thing to here, I will have to walk to the end of this train until I find null. I have to travel. If it is 2 carts already there, I will only walk 2 carts. If there are 2 million carts there, I will have to walk 2 million times. And this is when it gets really time consuming. If you have a linked list that is of massive size, you will have to walk all the way to the end of that linked list to find the last element. It's not really an element, it's a node, but you get the idea. So if I am planning to attach this to the end of my train, I'll have to walk along my train and find where it says null. And then once I find it, I have to start pointing it to 176. This is what I have to do. And let me do this in code. For you to be able to walk to the end of this train, you will have to start a new variable, define a new variable, and put it to the head. Because you want to put it on the head and start moving, and start moving, and start moving, and start moving. This way, you can traverse all the way to the end of the train. But you may say, how? Well, you will have to use a while loop, and you will ask a question. Your question is, while I'm moving, can you find any instance that the next is null? because I'm looking for the end of the train. And this statement here says, as long as you have not found the end of the train, keep going. Go as long as you find the end of the train. And for that, you will take your current and you will move to the next node. You keep moving next, and every time you're asking a question, you're saying, I have moved to the next. Is it pointing to null? If it's not, go to the next. Is it pointing to null? If not, point to the next. Is it pointing to null? Yes, you found the end of the train. Because now you have found the end of the train, attach your new node to the end of the train. And how do you attach your new node to the end of the train? Well, you say, for my next pointer, attach new node. In other words, when you find your train was going through this, as an example, and it was pointing to null, so this loop continues 3 times, as an example. Why would I think it continues 3 times? Because it looks at this, and the question is it pointing to none? No. Okay, let's look at this. Is it pointing to none? No. Then look at this. Is it pointing to none? Yes, I found the end of the train. When you find the end of the train, you have already prepared your new node. Your new node is ready. For example, it has 451 and it's pointing to null. You will make this connect to this. And that's how you attach the last train cart into your train. And the last thing which is going to complete this function is literally what the task asked me. The task, if you remember, asked me to return the head. Let me show you. When I was reading this, it says, returns the reference to the head of the modified linked list. That's it. So that's what I have done, return the head. I'm going to copy this code, and let me just drop this down, and I'm going to overwrite this definition of function, paste it here. Let me see if all the indentation looks good. Yeah, it looks correct. I'll move my face to the other side, run the code. Come on, mate. Thank you. Submit the code, and all test cases were correct. Okay, I really hope you enjoyed this video. If you did, hit the like button and subscribe to my channel. Let your friends know about my videos. It really helps me expand my audience. And if you're keen to get a data structures and algorithm course, just let me know. If I have enough interest, I'll create a full-on course that you only have to watch that, and then you don't really have to worry about anything else. Thank you very much.